There are two different ways to configure Loopguard. You can configure it in global configuration mode with the spanning tree Loopguard default command, and by doing so, every single point-to-point link on that switch will have Loopguard enabled for it. Or you can do it on an interface-by-interface basis using the spanning tree guard loop command. Let's examine that on ASW1. So ASW1 in our topology, let's focus on show spanning tree for VLAN 10. We'll see here that gigabit 0/1 going up to DSW1 is the root port, and gig 02 is the blocked port and the alternate state. What we want to do in this particular case is we want to configure Loopguard globally. So we'll use the command spanning tree Loopguard default. So in this case, Loopguard should be enabled on all of the point-to-point links within the spanning tree topology. So gig 01 and gig 02 should have Loopguard enabled now. How can we verify that? Well, if we look here, we can see that we have two options. We can look at the show spanning tree interface detail command, or we can even use show spanning tree summary to see how it was enabled. So on ASW1, let's type in show spanning tree summary totals. And we can see here that Loopguard has been enabled using global configuration mode. So Loopguard default is enabled. And if we examine the output of show spanning tree interface gigabit Ethernet 0/1 detail, we can see from this output for VLAN 10, Loopguard is enabled by default on this port, indicating that it was enabled because of that global configuration mode command. And if we examine 0/2, which is another point-to-point link, Loopguard has been enabled there as well for VLAN 10. So when you enable Loopguard, it's enabled for all VLANs. So if we look up here, you can see VLAN 1, Loopguard is enabled. Same thing would be true for VLAN 20 and so on and so forth. So by doing it on the interface or doing it in global configuration mode, all VLANs are affected by that particular configuration. But what I want to do now is I want to show you what happens when a failure occurs, that loop inconsistent state for the port. Let's go to DSW2 and suppress the sending of BPDUs to simulate a failure. So we'll go to gig 101 and we'll stop the BPDUs from being sent from DSW2 to ASW1 by using spanning tree BPDU filter, spanning tree, BPDU filter, there we go, enable. So now we've suppressed the sending of BPDUs, and we should see here shortly that ASW1 will place gigabit 0/2 in the loop inconsistent state. Now my syslog messages only say VLAN 1 and VLAN 20, but is that accurate? Well, we can use the command show spanning tree inconsistent ports, and you can see that, well, not all the syslog messages were displayed. In reality, all four of these VLANs that ASW1 knows about for gigabit Ethernet 0/2 have been placed into the loop inconsistent state. So don't just rely on those syslog messages. Take a look at the output of show spanning tree inconsistent ports to truly verify which of those interfaces based on the VLANs are in the loop inconsistent state. So we can see that right here in this particular example. In addition, you can look at the output of show spanning tree interface gigabit Ethernet 0/2 detail. And look what it says. It says, for VLAN 10, it's broken. It's in a loop inconsistent state. So it's telling you that there. And if you examine the output of show spanning tree, we'll just focus on VLAN 10. It even says right here, gig 02 is broken, BKN. And there's a star beside it. And if you examine the star at the very end, it says it's in the loop inconsistent state. So there's a lot of ways that you can verify that the port's in the loop inconsistent state. So how do we recover from this loop inconsistent state? We have to fix the spanning tree issue that has occurred. And in this case, it was all because the BPDUs are no longer being sent from DSW2. So let's go ahead and stop this issue from happening, and we'll see if the port is unblocked. And wow, it happened instantaneously. We are now unblocked. So let's look at the output of show spanning tree, inconsistent ports, and there's no more inconsistent ports in this case. So it has an automatic recovery feature built into it. As long as the BPDUs start coming back to that interface, it can be taken out of the inconsistent state.